final code from Part 1 is available on my website. We're going to add features to our BigFraction class. Let's take a look at it and see where we are. Okay, we have thus far created a constructor, a general purpose constructor for doing a whole lot of things. And then we have and what the constructor guarantees is that any negative is on top, that there's no zero denominator, and that all big fractions are born fully reduced. We have a toString method that displays our big fractions, and we have a couple of little test cases down here. Now, one thing, you can see that this is really kind of clunky looking, and this is the sort of thing that you might want to abstract away. Now, just to imitate what goes on in the big integer class, we're going to make a static factory method. So we're going to make this method return a big fraction. And you guessed it. We're gonna pass in a long that's in a num and a long that's a denom. And so what do we have to return down here? We're going to return new big fraction of big integer integer dot value of num, and then I'm going to return big integer, or I'm going to pass in big integer dot value of denom. Okay, and bingo. Let's check our parentheses. And the other thing we need to do, of course, is give this a name. This is not a constructor. And so its name is going to be, big surprise, value of. So we can pass in a long that's a numerator, a long that's a denominator, and we can promote that all to a big fraction. Now, let's come down here and see what that saves us from doing. This big hairy thing, all right, I'm just gonna comment this away so it's still there, but you can say big fraction f is big fraction because it's static dot value of 2, 3. That looks a little nicer and a little trimmer, and let's just test it out and make sure that everything is okay. You never want to get far from the compiling state of a program. Yep. Let's see if it looks all right. It looks all right. So now we will go in there and let's convert the rest of them. I'll leave the first one commented out as an example, but I'm going to go ahead and do this. Friction dot. Okay, and now I can just get rid of that. Oh my goodness. This becomes so much nicer when it's smaller. And we can even get rid of that extra parenthesis. And the verbosity of this just is less. This will make things easier to work with. All right. Oh, I got a little overzealous. Okay, 1048576. All right, let's get rid of that 4 that's at the end there. There's G and H. Oh, let's get rid of this cruft. And I'll go ahead and pop an F in there. And then let's just see that everything is still good. All right. And our code becomes shorter because we did a kind of a smart thing. It's going to make it more attractive to clients too. Bam. Okay, beautiful. Now let's try on a little arithmetic. So we're going to try to make an addition method. How does that work? Well, if you look at what big integer does, it makes a method public. It returns a big integer, but we're going to return a big fraction here. And I'm going to entitle that thing add. Okay, that. Okay, that is the name of the other big fraction. I'm this, he's that. Fair enough? Okay, so here's what you want to do. You know from your Wormwood days that this is true. A over B plus C over D is equal to AD plus BC divided by BD. I don't like your beady little eyes. All right, so what do we return? A and B are going to be my num and denom. C and D are going to be that's num and denom. So I'm going to say something like this. I'm going to say num dot multiply of that dot denom. Okay, that's AD. Then I'm going to add that to denom dot multiply that dot num. And there it is. That's AD is the thing before the add. BC is the thing after the add. And I'm returning that. All right. And I'm using, where did the multiply and the add come from? Num and denom are big integers. So it is cricket to do this. So whilst I'm here, I'm going to come down here and I'm going to say system.out. Oh, let's go down here. Of f.add of g. Now we're adding 2/3 to 1/2. All right, 2/3 plus 1/2. And if you get out your Mrs. Wormwood pen, 2/3 is 4/6, 1/2 is 3/6. You add them together, you get 7/6. So we should see 7/6. Okay, coyotes, put up your umbrellas and wait for the anvils. Let's see what happens. Oops. Bloody semicolon. All right, take that. No. Uh-oh. Big integer cannot be converted to big fraction. What happened here? Big integer. Oh, wait. Oh, I know what we did wrong. We forgot something. We did AD plus BC, but what didn't we do? We didn't divide by BD. Well, how do we do that? You know what I'm going to do here? Is I'm going to call this thing top. And BD is nothing more than denom times that dot denom. And then I'm just going to return a new big fraction of top and bottom. Okay, we forgot a step because we got so far down into the weeds with the numerator, we completely were oblivious about the denominator. So here's top and bottom. That's what happens when you code live. It's dangerous. That's why we compile often. Hey, wait a minute. What type did we give those things? They should be big integers, and we said big fraction. Whoops. Yes. Let's try that again. Yes, okay. Hey! Okay. Let's let the rubber meet the road, just for fun. Here, let's come down here and do something crazy. Alright. Oh, before I do that, I have a little bit of envy. I would like 0, 1 and a half to be static constants. So let's go ahead and stick that stuff in, because it's just going to make our lives better. Alright. Now, remember, things which are static are not state. State refers to the actual instances, the fractions themselves. This is going to be a property of the class as a whole. And so I'm going to go public, static, final, big integer, or big fraction, dot 1. Then we're going to make 0, and we're going to make half. And you can add others if you want, if you find them to be useful. Now, when we make these things, the smart thing to do is put them, initialize them in a static block. 1 is equal to there you go. All right, and I'm going to make this be 0 and half is going to be big integer dot value of 1 and 2. All right, and let's just compile this and make sure we're happy. Ooh, what did I do? I said big fraction dot. No. All we got to do is say the names. Control V. All right, I went a little overboard there. Sorry about that. Thank God for visual mode. Look at that. We just cleaned that up. But that's how you call them. You say big fraction dot those things. And wait a minute. I'm still missing something. Final. Oh, yes, this is big fraction. It should. I put the dot in there and shouldn't have. All right, you're going to make similar mistakes to that. That's life. And let me get rid of these spaces. It's an anality thing. All right, so now, see why I compile early and often? Oh, what are we missing here? Oh, we're missing this stupid space. Ah. All right, let's get rid of that. Okay, now let's go back in here. Yeah. Oh, good grief. Okay, what did I do here? I said big integer here, and I said should say big fraction. Okay, Got all kinds of problems. But we'll just whittle them down until they're gone. You lived through a similar thing, I assume. Good. Okay, now here comes a small test. Okay, I'm going to say big fraction total is equal to big fraction dot 0. So we're going to use our static constant for int k equals 1, k less than or equal to 100, k plus plus. I'm going to say total equals total dot add of big fraction dot value of 1 comma k. Now you'll notice I'm using integers, but this expects longs, but an integer will upcast into a long without any problem at all, so I'm not particularly worried. Print ln. Oh yeah, let's see what it looks like. Okay. Oh, oops, I'm missing an I. I'm missing an I. Big fraction. Aye, aye, Captain. Okay. We just computed the 100th harmonic number. Now, if you want to see what this is, I'll tell you a sneaky way to do it. Just grab it, copy it, open a Python session. Now, let me compute the log of 1,000 import math. And let's do this. Let's do paste minus log of 1,000. Oh, math.log of 1,000, please. Okay, so we're not far off. Oh, we did this for only 100, so we should do this for 100. Whoops. Ooh, that's mighty close to Euler's constant, which is 0.577. And if you don't know about Euler's constant, you will Wikipedia and look it up. Okay, so let me bail out of Python here. And you will see we've added some nice features here. We've added a static factory method to go along with our constructor, so we don't have a clutter of constructors. Now, one thing you might want to do, let's go ahead and do this. You know that I'm going to add a second constructor that looks like big integer. Now we know that one of the main constructors of big integer takes a string so I'm just going to do this. I'm going to call the sibling constructor with this, and I'm going to pass in a big integer that comes from the numerator, new big integer of denom, and we'll try that out. Let's go ahead and try that out. So I'm going to say big fraction x is is equal to new. And let's just put something in here in quotes, 1331. All right. Happen to know that's 11 cubed divided by 726. Let's throw that in there too. And when we do this, what should we know? This should be 11/6, I hope. So that's a test that I'm going to put this through. And see if it runs. Oh my God, it compiled. That's spooky. It compiled without complaint. 11/6! Yes! All right, so we are now in some pretty good shape. Now I'm going to throw in one more thing before I wind up here. And that is, we're putting an equals method. And because of the way we've rigged things, the equals method is going to work very, very easily. We're going to get away with murder. You will see. All right. So where's our toString method? Because I like to cluster those things together. Okay, here we are. Here's our public Boolean equals. Right? Because we want to compare for equality here, right? Yes. All right. So inside of here, I'm going to note this. Because the fractions are fully reduced, and because the negatives are always on top, you do not need to cross multiply. That would be an extravagant waste of time. All you have to do is return this. Oh, we need to put in our signature here. Remember, our signature is object, as you learned earlier. And I always like to call it O. That's sort of a standard thing I do. And if bang, O instance of big fraction, we have goose cookery here. If it's not of the right type, it fails the species test. We return a false, and it's all over right here. Otherwise, what do? We first have to perform the guaranteed cast. Big fraction. That is equal to big fraction cast of O. And remember, the reason we can do this, if the object is not a big fraction, we're out. We've returned. We're done. So it is guaranteed 100% that I'm going to be able to do this cast. Once I do the cast, I am going to return num.equals that.num. I'm going to compare the denominators, and num.equals that.denom. Okay, there's my equals method. Equals methods are always written in this standard way. Species test, cast, and then usually what you're doing is you're checking for equality of state. Most cases, that's what you're doing. You're checking for equality of state with some Boolean operations, and we have a nice equals method. Let's go ahead and test it out. I'm going to make a big fraction. All right, and I'm going to say system.out.println. %s g gag g dot equals gag. All right, and that should come out as a true. The two-string methods are both going to show a half. They're not going to show what somebody passed in because we don't care about the unreduced form. Compile time. Whoa. Oops. Oh, I know what I forgot to do. Let's go down into main and make that happen. It's a common omission. Yes, it's not println, it's printf. I'm doing formatted printing, and I often forget and put an ln there, and then I get that. I get all kinds of god-awful messages that look dire, but are caused by one trivial thing. Hey, look at that. One half equals 1/2. Ooh, that's not good. False. I wonder why that is. Let's go down and check that out. It always pays to test things. Okay, if you're not a big fraction, return false. Num.equals. Oh, there we go. It's denom. Dot equals that dot denom. Figures. Okay, now it's going to compile. Hey, look at that. And our equals method is working. You know, we would subject it in reality to more rigorous testing than that. But I think now we're in a pretty good state. So, to summarize what we did today, just a little bit, we went ahead and added static constants because they're useful. And you can see that they are. We did not change our constructor in any way, but we added a new one. So we kind of look like big integer. We just take two strings instead of one. We created a value of static factory method that you pass in two longs and it turns it into a nice big fraction. We created a two-string method. Okay, we created that last time. We created an equals method that checks for equality, and because of the way we engineered things, it's looking like the way we engineered things is smarter and smarter as we go along. The equals method is really rather trivial to write. You know, no cross multiplication. You're simply comparing the numerators and denominators. We put in an addition in the form of addition, and we tested that out by computing the 100th harmonic number and seeing that the 100th harmonic number is only about 0.58 distant from log of 1,000, and that's what you'd expect if you were a self-respecting calculus student. Okay, and then here we just printed it out. So I think this will be sufficient for now. Later, we're going to go in and introduce more arithmetic, but you may find that before you watch the next video, you might want to take a shot at this yourself. And then the next video will take you through a guided tour of what I did and compare what I did to what you did. And let's see how you like it. So you could add subtract, you could add multiply, you could add divide. And I think it's actually a smart idea. Try adding negate. And, look at big fraction and the things that you think are big integer and the things that you think are pertinent, you can add to this class. But we'll be adding more to it. See you next time. And good luck trying to implement those things I had suggested.